Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from October-November 2021, paper 4, variant 1. In this lesson, we will discuss how to calculate angular frequency of oscillations and how to calculate maximum speed of oscillating body. We will also discuss how to deduce information about oscillating body when displacement against time graph is given to us. At the end of this lesson, we will discuss how to sketch velocity against displacement graph for simple harmonic motion. For question number 4, it is given to us a trolley on a track is attached by springs to fixed blocks X and Y as shown in figure 4.1. As you can see here in this figure 4.1, we have one fixed block Y. This one is fixed block, means it cannot move. We have another block X. This is also fixed block. This block also cannot move, and the trolley is oscillating between these two fixed blocks, and trolley is attached to these blocks by spring. So these are two springs. It is also given to us track contains many small holes and air is coming out of these holes vertically. So air is coming out vertically upwards, and this air will reduce the direct contact with the track, or simply we can say air will reduce friction between trolley and ground. It is also given to us the trolley is pulled to one side of its equilibrium position and then released. So it oscillates initially with simple harmonic motion. After a short time, air blower is switched off. Variation with time t of the distance L. So here is the distance L of the trolley from block X is shown in figure 4.2. So this is figure 4.2. From this figure, we can also see at the beginning, you see this motion is undamped. So you can see this motion is undamped. So until this point, we have air blower on, mean air is coming out of the holes, and after that we switch off air blower. So you see damping start after that. So this is the damping. So you need to get the basic idea about this question. So the main purpose of reading question and explaining a little bit about graph is to give you the main picture of this question. I hope now you have clear picture. We can go to next and we can answer question. For question A1, we need to determine the initial amplitude of the oscillations. But if you look at this graph, we can simply find out when L is equal to 20 centimeters, trolley is at equilibrium. So we can also draw this line. So you can draw this horizontal line. We can now see very clearly that this is the equilibrium position when L is equal to 20 centimeters. So the maximum displacement of this trolley from equilibrium is 5. 25 minus 20. So that is 5. So it's better to write on 5.0 centimeters. So this is initial amplitude of oscillation. This question has only one mark, and that is answer mark. If you have written 5.0, you will get this 1 mark. For our second part, we need to calculate angular frequency of oscillations, and angular frequency is equal to 2 pi over capital T. Capital T is the time taken to cover 2 pi radians angular displacement. 2 pi radians angular displacement simply means one cycle, or we can say one oscillation. So this time is the time period. So simply we can write down capital T here. This is the time period. Now, if we have value of time period, we can calculate angular frequency. So if you look at figure 4.2, we can find out that this is one complete oscillation. So this time taken is equal to time period. Now simply we can plug in value of capital T here. Capital T is equal to 4. And we can cancel this 2 with 4, so simply we left with pi by 2, and pi by 2 is equal to 1.6 radians per second. So our final answer is 1.6 radians per second. This question has 2 marks. The first mark you will get if you have written the right formula, means you have written this formula, you will get first mark, and that is C mark. You will get 1 mark. And the second mark you will get if you have got the right answer. If you have got the right answer, you will get in fact 2 marks for this question. But if your answer is wrong, you have written this formula, still you will get 1 mark. For the next part, we need to calculate the maximum speed of the oscillating trolley, but our answer has to be in centimeters per second. Maximum speed, first of all, let me explain to you how you can calculate. Vmax is simply equal to A times omega. A is the amplitude. If you multiply this one with angular frequency, we can find Vmax. A we have already calculated in part A1, that was equal to 5.0 centimeters. And value of omega we have calculated here, but this value is up to 2SF. This is not the exact value of pi by 2. If I divide pi by 2, the exact value will be 1.57. So in next calculation, we will use the exact value. So I'll be using here omega is equal to 1.57 because this is approximately equal to 1.6, mean up to 2SF. So that's the reason we have written here 1.6. This is correct answer. Now we are using exact value of omega here. Now if you do this calculation up to 2SF, our final answer will be 7.9 centimeters per second. It's better to use the exact values in the next calculations. So this is a good way, this is a good science. So always try to use exact values in the next calculations. And so our final answer is 7.9 centimeters per second. And this question has 2 marks. The first mark is if you have used this formula. If you have written this one, you will get 1 mark. And that is C1 mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. But if your answer is wrong, you have written this one, you will get 1 mark. So always start by writing formula and then plug in numbers and then do calculations. Let's try to understand how we got this formula. Means how do we know that Vmax is equal to A times omega? In the formula list, you can find out V as a function of X. This is equal to plus minus omega times A square minus X square, and this is given in formula list. On third page you can find out this formula. Now if you need to find Vmax, means you need to find out Vmax, and V is maximum at X is equal to 0, means at equilibrium position the speed is maximum. Now simply from here we can find out, means V at X is equal to 0. This will be equal to plus minus omega, and X is 0 in this case. So we can say A square minus 0 square. From here we can simply write down Vmax. This will be equal to A times omega. So this is how we got this one. Vmax is equal to A times omega. You no need to worry about plus minus sign. We are talking about speed here, so we no need to worry about plus minus. So this is how we got this formula. For part B, we need to describe what may be deduced from figure 4.2 about the motion of the trolley between time t is equal to 0 to t is equal to 24 seconds. Means when time is equal to 0 to time is equal to 24 seconds. In this interval of time, we have to describe the motion of the trolley using this graph. And it is also given to us no calculations are required. And we no need to include the quantities we have already discussed in part A. And this question has 3 marks. It means at least 3 points we have to write down to get 3 marks. So first of all, let's start from here. So you can see here, first of all, displacement is positive. So this displacement is positive. And by convention, we take to the right is positive. You see L is increasing and this is positive. It means the trolley is pulled to the right. So simply first part we can say trolley is initially pulled to the right. So this is can be our 1 point. It is pulled to the right initially. So this is 1 point we can write down. And the second point we can write down, period of oscillations. This is equal to 4 seconds. So this can be the second point. We can say the period of oscillations. This is equal to 4 seconds. So this can be the second point. Now, if you look at amplitude of oscillations, we can simply see that until t is equal to 12 seconds, amplitude of oscillations is constant. So this motion is undamped. So we can say initially motion is undamped until here, but after that amplitude is decreasing. So this is damped motion, or you can say oscillations are damped. But if you look at amplitude, how it is decreasing, this is decreasing gradually, means exponentially this is decreasing. And this kind of damping is light damping. So we can say this is light damping. So this can be our third point, and this one can be fourth point. That we can also talk about maximum speed. So this is the equilibrium position. So this here time is equal to 1 second. So the speed will be maximum. Here time will be equal to 3 seconds. Speed here will be maximum. Speed here is maximum. Speed here is maximum. So we can say the speed is maximum. We can write down V max at t is equal to 1 second. You can also say t is equal to 3 seconds. From this graph, we can also find out when the trolley speed is equal to 0. The speed of the trolley will be equal to 0 when its displacement is maximum, means at this point its displacement is maximum, so trolley will be stationary. At this point trolley will be stationary. At this point trolley will be stationary. At this point trolley will be stationary. So simply we can say trolley will be stationary when t is equal to 2 seconds, mean I'm talking about this point. Initially it started from rest, so initially at rest, you can also mention about that point. We can also say trolley is stationary when t is equal to 4 seconds, mean at this point. Even you can also say trolley was stationary at t is equal to 0, and so on. So you can see we can deduce about 6 points about motion of the trolley from this graph. And question is asking us to write down only 3 points. If you write down any 3 of these points, you will get 3 marks. Now let me show you how we can write down a proper answer for this question. For this question, you can write down these points. So you can see the first point I have written here means the trolley is pulled to the right. You will get 1 mark. Second mark, you can say period of oscillations is 4 seconds. You will get 2nd mark. And the 3rd mark, you can say initially motion is undamped, as we have discussed here. Motion is undamped until this point. Maximum speed is at t is equal to 1 second, means the speed is maximum here. Speed is maximum here, and the trolley is stationary at this point, at this point, at this point. Means t is equal to 2 seconds, 4 seconds, even 0 seconds, you can say, as we have discussed here. This part. Damping is light, we have discussed here. So you can write down any 3 points, you will get 3 marks. And each mark is B mark, means this has to be in your answer. You can include any 3 points from here. For part C on figure 4.3, we need to sketch the variation with L of the velocity V of the trolley for its first complete oscillation. First complete oscillation, so this one is the first complete oscillation. So you can see from here, in this case, the speed of the trolley is maximum at this point. So speed of the trolley is maximum at equilibrium, and at this point speed of the trolley is also maximum. So simply we can say V is maximum, and the maximum value of V we have already calculated, that was equal to 7.9 centimeters per second, and this is maximum at L is equal to 20 centimeters. We can also see from here the V is equal to 0 at this point, means when L is equal to 15, so V is equal to 0 centimeters per second. We can say at L is equal to 15 centimeters, and this is also equal to 0 at this point. Initially it is 0, so we can say L is equal to 25 centimeters. And again, when it will complete cycle, L is again equal to 25 centimeters, so V is again equal to 0. Now simply we have to use this in informations, and we can sketch the graph. First of all, look at when V is equal to 0. So V is equal to 0 when L is equal to 25 centimeters. Mean at this point V is equal to 0. And V is equal to 0 at this point as well. V is maximum when L is equal to 20 centimeters. So here 20 centimeters. And the value of the V is 7.9. So this point is 5 here, so this one will be 6, this will be 7, so here will be 7.9. So 7.9 about at this point. So we can also find out v when it is maximum here. So this will be 6, here is 7, so here is 8, means 7.9 about here. Now we need to join this point, and the shape of this graph will be elliptical because v is equal to plus minus omega times a square minus x squared. So the shape is going to be elliptical. So simply we can say in this case shape of the graph will be elliptical. So we just need to join these points. Now let me show you how you can sketch this graph in a proper way. So this is how I have sketched this one, and you can see this is a proper shape of this graph. So this is how you need to sketch.